So we're going to look into how we could possibly sketch the graph of a plane, that surface in 3 dimensions. So to get started, whoa, wait a second. That doesn't look like a plane. I thought our plane looked like this. That was what our plane looked like. This has some similarities to it, but it doesn't quite look the same as this. All right, I guess I have to convince you all, and maybe even myself, that this really does fit the model here. We're going to subtract 12 from both sides. And we can associate the 12 with any one of these 3 terms. We could break the 12 into 4, 4, and 4 and associate it with any one of these terms. I'm just going to do the following rewrite. We're going to subtract 12 from both sides. I'm going to organize it this way. So it at least equals 0, like the equation of the plane has been for our last few segments. And let me factor out the 2 here. X minus 6. And let me just do a little redecoration. Let's call this 3 times y minus 0 and 4 times z minus 0. Now that is a plane right there. That is a plane. Its normal vector is 2, 3, 4. Recall, that's not coordinates, that is the direction the vector sticking perpendicular to the plane goes. Yes, the correct term is normal to the plane. And if I use this equation here, I would get a point 6, 0, 0. 6, 0, 0. Now, on to the sketch. We're not going to, in general, sketch planes in my classroom, just any old plane. But we will look at one type of sketch that is not too difficult to tackle. And let me just go back to my original equation here in case it leaves the screen. 2x plus 3y plus 4z equals 12. Can we look at this and say, if x is equal to 6, then 2 times 6 is 12, and so y and z would have to be 0. And if this is the z-axis, and this is the x-axis, and this is the y-axis, then that point 600 is right here. It's 6 units out along the x-axis. Now, I wonder, 3 times 4 is 12. If y is 4, 3 times 4 is 12, then let x and z be equal to 0. So that would be our y-intercept is 4. And finally, if you haven't guessed what I'm going to do next, 4 times 3 is 12. If z is 3 and x and y are both 0, 0, 0, 3 is the z-intercept. Well, those 3 points make up a plane. We recently did a little video where we took 3 points in a plane and wrote its equation. I'm now taking the equation and finding 3 points, and we're going to say that this triangle is part of our larger plane. All right, so the plane might be tilted in such a way, but this triangle is going to be our graph. When we graph a line in algebra, I can draw an arrow that says it goes that way. But this triangle will expand. If I had a different type of coordinate system, maybe it would be a circle, and the circle is on the plane. Or pick your favorite planar shape to represent the plane. We're going to use this triangle to represent the sketch of our plane. One more little detail, when we're in the location of the graph where x, y, and z are positive, this is called the first octant. It might not be too difficult to draw using a similar trick in one of the other octants, but when I ask you to sketch a plane in my classroom, it's pretty much going to be done in the first octant. Okay, till next time.